In this video, I will show you how to sketch the graph of a rational function using a sign chart. So first step is to write the domain of a function. And to find the domain of the function, we have to factor out the denominator. So in this case, we have x minus 2 times x plus 2 times x plus 4. So that means the domain of this function is all the values except 2, -2, and -4. Second step when graphing rational function is to classify the discontinuities. So since function is not defined at 2, -2, and -4, we would like to know what's happening at those points. And to classify the discontinuities, we have to now factor out the numerator and try to reduce the function, meaning we want to divide by what the numerator and denominator have in common and write this expression in the simplest form. So here we see that both have x plus 2, and we're going to reduce this rational expression by x plus 2. So since there is no x plus 2 in the denominator anymore, we classify x equals -2 as removable discontinuity. The other two factors are still in the denominator, so we classify them as vertical asymptotes. That means we can already graph these two vertical asymptotes on the coordinate plane. So we have an asymptote at 2, and we have asymptote at -4. Once we found vertical asymptotes, next we want to try and find horizontal or slant asymptotes. The rule is very simple. So a rational function has, if it has an asymptote, then it can be determined by considering the quotient from dividing the numerator by the denominator. So in our case, the degree of the, what do we have in the numerator? We have a polynomial of degree 2, and in the denominator we also have polynomial of degree 2. So since we don't care about the remainder in that division, and we only care about the quotient can be determined just by looking at the leading terms. So that means the horizontal asymptote of this function is y equals -1 because of this quotient. So we can immediately graph this horizontal asymptote. Now remember that horizontal asymptote only tells us what the graph behaves like as x goes far to the right and far to the left. So horizontal asymptote does not mean anything in the middle. So now we have all the asymptotes, and step 4 is to construct the sign chart. To construct the sign chart, we're going to use the function written in the simplest form, and we're going to look at all the factors, and regardless of whether that factor comes from the numerator or the denominator, we're going to label those points on the number line. So 5, 2, -2, negative 4. Now, the sign chart of this rational function is exactly the same as the sign chart of this polynomial function. That's just a fact. That means we can take advantage of our knowledge of polynomial functions and produce the sign chart for this rational function. Since the corresponding polynomial function is negative x to the fourth, or the graph of the corresponding polynomial function looks like the graph of negative x to the fourth, we conclude that the sign chart has negative on the right and negative on the left. And since each 0 has odd multiplicity, that means the signs will change at every interval. So here it's going to be plus, minus, plus, and minus again. Now, in order for us to graph it, the rational function, we need to interpret this sign chart. So we're going to start by placing all the x-intercepts on the x-axis. So we have x-intercept at negative 2 and 5. We have asymptote at negative 4 and 2. And now, one by one, we're going to interpret every sign change. So for example, what happens at 5? At 5, the function goes from negative to positive. So how does it look like on the graph? Well, it's going to look like this. What happens at 2? At 2, we have an asymptote. On the right side, it's positive. On the left side, it's negative. So what does that mean? That means on the right side, the function will go up. On the left side, the function will go down. What happens at negative 2? At negative 2, the function is positive on the left, negative on the right. That means it looks like this. And what happens at negative 4? At negative 4, the function is positive on the right and negative on the left. And also, the last thing to interpret is the horizontal asymptote. So y equals negative 1 means the function follows this asymptote y equals negative 1. So now we just have to connect these pieces together, which is not that hard. So going from left to right, function is negative, then it becomes positive and goes to infinity. Then it appears on the other side, goes here, crosses, and goes to infinity. Then it appears on the other side and goes to y equals negative 1. So this is how we use a sign chart to sketch the graph of a given rational function.